Hey everyone, so in this example we want to create a nice little effect that is based on those pin toys or pin screens that you might remember from the 80s. And what we want to do with this now is we want to go even one step further and we want to animate them based on a sequence of an image. So what we need, of course, is those pins that are positioned in a grid. And the easiest way of creating a grid, of course, is actually create a grid node. Because here we have actually, of course, faces based on a grid. So let's choose something that kind of makes sense for us, maybe something like this. And let's be careful with the scaling, maybe say exactly 5 by 10. And then we can make sure that the faces that we use here will be squared. So let's make sure that the rows are exactly 100 and the columns are 50, something like this. And then we have a resolution that makes sense. Now to bring in a picture, we already know what we need to do is an attribute from map. There you have it. And what we want to use for this is an animation that you might have seen before from MyBridge, an old black and white recording of a horse riding. So here we go. And it is a bit deformed. So first of all, let's make sure that it works for you. When you bring it in, it has to be a sequence of frames. So it should look something like this, that there is a frame name in the name of each picture. And this is then brought in with a $F, or in this case $F3, which means it will create leading zeros. So make sure that this works for you, otherwise you will not see this animation. Now that it's working, and you can see here that the sequence is over, so let's go until it's over, maybe to frame 90. There you go. And what we can see is that the whole thing is deformed. So let's go into the attribute from map and go into the image settings. And first of all, we rotate this thing around, maybe to something like this. And then we flip it in V so that it makes sense. Now you should have a look at the actual pixel ratio of your picture so that you can find something that makes sense for your grid here, and then make sure that the same ratio is used for the subdivisions as we just saw. It's the same logic, so if you have to adjust this, make sure that you adjust the rows and columns accordingly so that ideally you have, square faces. So let's increase the resolution, so I can just multiply what I have here by just adding a multiplied by 2 and now have a higher resolution. And if I press play, you can see we have the actual sequence, maybe in real time. There you go, great. So let's turn this now into something like pins, and we will start with a technique that we already have seen, and that is by simply using a poly extrude. So with a poly extrude, we could use the attribute that we just created, which of course is CD. We could change this to another attribute, but this way we can see what's going on. And of course, what we have to use is under local control, we put it into the distance scale and set the distance to 1. And as we know, before I forget, we have to set the divide into individual elements. We've seen this before. And at this point, we should know why it's still not working. And that is because the attribute is a point attribute, but we need it on the faces. So let's turn it into a primitive attribute by using attribute promote. There you go. So we want to move the CD from point to primitive. And there you have it. Now we can see that our extrusion is driven by our sequence. Now I just realized maybe a lower resolution would be fine here as well. So maybe let's quickly go back and change this to what it was before, something like this, because then we can see the effect a little bit better. But you can already see there's a problem because our horse is dark and the surroundings are bright. We have the opposite of what we want. Now in the attribute from map, you would maybe think that you could invert the color somehow, and maybe you can. I think you can do it with a remap by turning the remap influence around or something, but I will show you another way. It's really helpful to understand how to invert values. The first way of doing this, and by the way, it doesn't matter if you do it here on the points or then on the faces, but just be aware that one is on the faces, one is on the points. So let's do it after the attribute promote. To invert those colors, we could, for example, do this in a primitive WOP, because the advantage of WOP here is that there is actually a node for this. And what we want to do is first of all, we want to turn CD to CD so nothing happens. And now we want to invert this. Now let's see if there's an invert node. Yes, there is, but be careful with this one. If you drop it, you can see there are 4 inputs. This is a matrix inverter. Matrix multiplication and math is a completely different topic. We actually talk about this in the Vex chapter if you're interested, but as you can imagine, this is really advanced and has nothing to do with what we're doing here, so let's ignore this right away. Then there's also a reverse. Well, here in this case, there's an array reverse. Outside, by the way, there is a reverse, that's why I said this, but a reverse will not help us because it will just turn our faces around. It will not change any kind of attribute. So here you don't even have a reverse. So how do you do it? Now the node that we're looking for has a weird name. It's actually called complement. Don't know why, don't ask me, maybe the mathematical term for this is complement. But what's interesting is here, it tells us what an inversion actually is. It's 1 minus x. So x equals 1 minus x. Please remember this because in a second we will do this in Vex, but for now all we have to do is we bring this in and bring the result out, and when we look at the result, there you go, we have an inverted version, which is, you know, good to know. You can do this with WOPs, you can invert any kind of value, and be careful, this value has to be between 0 and 1 for it to work, but since, you know, our brightness here is between 0 and 1, this is perfectly fine. And as an alternative, we can actually do this with a primitive wrangle, because a primitive wrangle can do the same thing. We just have to do it by hand, and we just saw that basically the logic is x equals 1 minus x. What does it mean for us? Well, color equals actually 1 minus color. This will actually work, as you can see here, surprisingly. So keep this in mind. This has nothing to do with Houdini, of course. This is just a general thing. This is what Photoshop is doing as well. So I find it really helpful, those small little tidbits of logic, because this will help you for the rest of your CG career to know what an invert actually is. Okay, so now that we managed to do this, we can use this as an input for our poly extrude, and as you can see, cool. Now we have here something that we wanted to see, and it's even moving, which, if you ask me, looks pretty cool. So awesome. This is pretty much the logic, and we could stop here, but we want to do it even nicer because, of course, when you look at the actual reference, this is not how those toys looked like. They weren't made of squares. Even though this is kind of cool, a square is not the goal here. So instead of this, I created already for us a little pin. Nothing too hard to do for you. So something like this maybe, and we will copy this, of course. And this is just a cube, and I copied a sphere on it that is scaled, and then I used a match size, and this is interesting, to move the whole thing so that the tip is at the center of the world. So create your own pin, and once you have it, let's copy our setup here, and what we need here is probably this part. And basically what we want to do now is we want to take this grid, and since we now work with point attributes again, we can use a copy to points directly, because every single point here will be where our pin will later be. So let's do this. We take this as an input, and then we copy this pin, and it looks like this. There's a problem with this, of course, now, because when you look closely, our pins are now moved to the side. Well, we know why this is, because it tries to align the z-axis towards n, which is kind of weird. But in our particular case, there's a very quick and easy solution. We just ignore the transformation completely, because all we want to do in this case is really just copy it to the position. And here you can see this is kind of neat, but there's a big gap in between each of the pins. So let's quickly fix this. We can do this by hand here by simply transforming the whole pin up to a point where the pins meet. There are ways of kind of doing this procedurally if you really want to. Maybe that's something for you to think about, but in this particular case, it's not necessary. We just need the pins to connect like this, and then we have, you know, the pins connected. And now we don't need the color actually. So for now we could override this with a normal color node, but before that we need the color for something else, and that is, of course, to control the height of our pins. You could do this after you copied the pins, but keep in mind really what you care about is the position of those points here on the grid. And it's actually quite simple to build this in. We can do this directly with Vex, for example, and let's call this pin height or something. And really what we need to do is we want to say the height equals the inverted color. So in Vex, this would be, okay, what is the height? It's the y element of p. And we just equal this to the color. That's all. And what we get now is again the wrong way around. And we can actually directly put in the inverted version, maybe something like this. And there you have it. It looks a bit weird now because we really just deformed the points of the grid, but keep in mind we don't care about the grid itself, we care about only the points. So once it's copied, we can see that this is actually happening to the pins, and if we get rid of the color, and by the way, I have a little environment light here created already, so let's make this a little bit brighter, and basically now we have a pin version. Let's run this, maybe with a little bit of an angle so we can see it in all its glory. Of course, it's a little bit slow now in the viewport. If you would flipbook this, we could watch this faster, which is something we'll look at in the next video. But as you can see, a pretty cool effect, right? If you add shaders to this and make this look metallic, it will look even better. So maybe this is something you can do for yourself. But before we finish this, because I showed Vex now, maybe you feel more familiar with WOPs. And in this case, we can do it with a point WOP. And it's basically the same thing. We turn the Y element of P, which is here, to CD. And for this first, we have to break up the vector of P with a vector to float, because we only want to change the Y element, but want to keep X and Z. So we have to go back to float to vector. There it is. And we want to keep X and we want to keep Z so that our position is fine. But we only want to change the Y element with CD. There you go. And now we just have to invert this. And luckily for us, we here have a complement that we can just stick in and we're fine. Of course, if you wanted to change the height of this, naturally you can do something like a multiply or even multiply at constant, because then you wouldn't even have to add a constant here. You can have a oops, sorry, no, wrong place, because I'm currently scaling X, Y, and Z. I actually only wanted to scale the height element, sorry. So now I can even change the height if I wanted. And if I want to do this in, let's quickly look at the result actually. So here, if I pin this, I can, change the height of my setup as well. If I'm not happy with it, maybe my pins are a bit too high or something like this, you can change the height. In Vex, of course, it would be the same. You can just multiply it here with a multiplier at the end. I would do it in a new line, maybe like this, with a parameter, and I call this height. And then we have kind of the same. Currently it's 0, and this is why it resets. And if I move it up, you can see it increases. There is actually another way to do this, by the way. If you wanted to do it afterwards, instead of before, you could just make sure that your pins are actually, which are made of multiple geometries, of course, are just packed. So if you pack them here with pack and instance, which by the way is a good idea anyway, because then as you can see when we press start, the whole thing is even much faster, because now each pin is instanced, so he's in the memory and will just be reused, which makes it much faster for Houdini to read it and display it. So this is a good idea anyway, but it also would allow us to take our function here and put it afterwards, because now what comes out of the copy to points is 1 point for each pin, because each pin is a packed geometry, and then the whole technique would still work, because now we would just move the pins directly represented by points. So this is another option that you would have to do the same effect, and in the end result, of course, it looks the exact same. So I hope this is helpful. It's a really nice little effect, especially when you shade this properly. Like I said, give it a nice metallic shader, a nice HDR, and a little bit of lighting, and it will look really nice. So I hope this is helpful and there were a couple of interesting things for you. Thanks very much. See you later. Cheers.